Yes. So I will start from what is called what? Hydrocarbon. Now, what's the meaning of hydrocarbon? These are the compounds that contain hydrogen and what? Hydrogen and carbon. That is what is called what? Hydrocarbon. We now have two types of hydrocarbon. We have what is called saturated hydrocarbon, and we said saturated hydrocarbon, they are the what? They are the hydrocarbon that contain single bond, and we have unsaturated hydrocarbon, they contain double bond. Now, saturated hydrocarbon are the organic compound that contain single bond, e.g. like sigma bond, and which all the carbon atom are what? Are sp3 hybridized. It means that it contain one sp3, or contain carbon what? Carbon single bond in between the adjacent side of what? Of carbon atom. An example of what is called saturated hydrocarbon is what? Is alkane. You know, when something is saturated, so it's full already, so you don't need to add anything to that particular compound again. So that is why we say it is saturated hydrocarbon. Type of what? Saturated hydrocarbon. We have what's called branching alkane, single what? Straight train what? Alkane, and we have what's called cycloalkane. What is alkane herself? Alkane are family that have general molecular formula of what? Of CnH2n plus 2. And we know that alkane is also known as what? Paraffin. And if you want to know how we make use of this formula, then when you have CnH2n plus 2, and how we derive all these members of alkane that we have here. Now, so you will start that, you say that when n is equal to 1, is that taken? Substitute that n into this formula. So wherever you see this particular n, you put what? You put 1. That is the reason why we have CnH2n plus what? CnH2n plus 2 is the formula. Then when you substitute the 1, it will be C1H2 into 1 plus 2. So it will give you CH4, which is what? Methane. Now do the same thing here. When n is equal to what? Is equal to 2. Is that taken? Then it will be what? Substitute that 2 into the formula. Then we have C2H2 into 2 plus 2. That's why we have C2H6. And it gives us what? Ethane. You do the same thing. Substitute when n is equal to 3 into that formula. You will get what is called what? Propane. Substitute when n is equal to 4 into that formula. You will get what's called butane. So then you will get the remaining one like this. That's how you are going to do the remaining one. Then another thing, you can see that we have CH2 here. Why do we have CH2 here? Because now there is something we call homologous series. Homologous series are a group of atoms in which each successive member are differed by what? By CH2. E.g. like this alkane, they belong to the same what? Homologous series. Now if you take a look at it very well, C3 minus C1, C2, we have what is called what? C. H8 minus H6, we have H2. So in that sense, it gives us what? They are differed by CH2. Go to this one too. C4 minus C3, we have C. H10 minus what? Minus H8, we have CH2 again. Then when you do it that way, you will discover that each successive member are differed by what? They are differed by CH2. If you subtract C5 minus C4, you will get C. If you subtract H12 minus H10, you will get what? CH2. Then so that's how you are going to do it. In that sense, it means that all these things, they are differed by CH2. When they are differed by CH2, it means they belong to the same what? Homologous series. And I define that homologous series are the series in which each successive member are differed by what? Are differed by CH2. What are the characteristics of homologous series? Since they are differed by CH2, it means you can prepare them with the same method in the laboratory. They will undergo the same what? Chemical reaction, and they will undergo what? Combustion. So that's the reason why you say they are what? They are they belong to the same what? Homologous series. So another thing entirely is that now if you take a look at this next one, there's something we call physical properties of what? Of alkane. That when you are talking about the physical properties of alkane, now there's something we call what? Molecular formula, and what? Melting point, and what? Melting point, and what? BP means boiling point, and what? This one means density. And if you take a look at this very well, this particular density, and you see that density, you see the molecular formula, you see the boiling point, then you see the density. It means the molecular formula is directly proportional to the what? Melting point. As the molecular formula increases, the melting point increases. As the melting point increases, the boiling point increases. As the boiling point increases, the density increases. Why the this one, you see that is 1 over v. As all those one increases, this v means volatility. Volatility will decreases, while the degree of branching will also what? Decreases. You can see it now. We have serial number here, and they are what? 1 to 10. And we have the name of Alkane family. They are also 1 to 10. And we have their what? We have their formula here. They are also 1 to 10. It means that as this serial number increases, the what? The molecular formula increases. In that sense, the boiling point will also what? Increases. The melting point will increases, and the what? The density will also increases. While the v, which is volatility, will what? Decreases. Degree of branching will what? Decreases. So that is number one. Number two is that they are non-polar solvent. That is, they cannot dissolve in water. In that sense, when they say something is non-polar solvent, you know we have two types of solvent. We have polar solvent and we have what? Non-polar solvent. Now the reason why there is difference between non-polar solvent and polar is that polar solvent, they are the solvent that when they expose to the atmosphere, they don't lose their polarity. Is that taken? That is, when you expose them to the atmosphere, they don't lose their what? Polarity. But non-polar solvent, when when they what? When they expose to the atmosphere, they will lose their polarity. E.g., in this particular petrol, if you put it, like if you expose it to the atmosphere, it will what? It will dry immediately. That is why they lose their polarity. Number three of physical properties again is that from C1 to C4, we call them gas. It means from methane to what? To butane, we call them what? Gas. Number four, they have no action on what? On litmus paper. It means that they cannot change the what? They cannot change the litmus paper to blue or to red. Then another one is what is called laboratory preparation of alkane. How do we prepare how do we prepare methane in the laboratory? You can see that the preparation of methane in the laboratory, whenever you see equipment and they make use of instrument to prepare organic compound, that means they want to prepare them in the what? In the laboratory. So example, e.g., like methane, it can be prepared in the laboratory by heating sodium ethanoate together with what? With soda lime in what? In that glass test tube. The colorless and the odorless gas evolve, which can be collected over water. It means whenever you are preparing methane, if you take a look at the diagram, especially in secondary school, you will see the methane on top of the what? On top of the water. That is the reason why they say that they collected over the what? Over the water. Why? Methane is a non-polar solvent, while the water is a polar solvent. And you understand that whenever you see methane, which is organic compound, it is a non-polar solvent, while the water is a polar solvent. And if you go back to your separation techniques, if you want to separate the what? The polar solvent from non-polar solvent, and you know that polar solvent, they are what? If you want to separate polar solvent from non-polar solvent, you will use what is called separating funnel, because they are what? They are immiscible liquid. So in that sense, methane can be prepared in the laboratory by heating sodium ethanoate together with what? Together with soda lime in hard glass test tube, because the reaction is very dangerous. At the end of the day, the colorless and odorless gas are what? Okay, the colorless and odorless gas evolve, and which can be collected over what? Over water. Can you see the sodium ethanoate? Can you see it now? If you remove Na, it will become what? Ethanoate. But because Na is there, we call it sodium ethanoate. Here is what? Our soda lime. Now if you now want to react it together, if you take a look at the reactant side, we have sodium ethanoate plus sodium hydroxide, and at this product side that give us, we have Na to CO3. If you want to know how we get the product, CH3 is here, and you will add the one hydrogen. CH3 is here, add one hydrogen to it, you will get CH4. Then in that sense, when you get CH4, what do you have left? Now what I'm saying is CH3, this is CH3. Take one hydrogen here, put it here, you will get CH4 at the product side. What do we have left? We have C, one carbon, abi. We have C. And what do we have left again? We have Na. 2Na, then you write Na2. How many carbon? We still have one carbon, you write C here. How many oxygen? We have three oxygen, 1, 2, 3. So that's why we get Na2CO3. So in that sense, if you want to prepare ethane, we will use sodium propanoate. If you want to prepare ethane, you will use sodium propanoate to prepare ethane. So in that sense, this is the what? This is the sodium propanoate, since we want to what? Prepare ethane. So in that sense, you have C2H5 here. Take one hydrogen from here, add it together to this place. At the product side, what do you have? C2H6. Then what do you have left? We have two sodium. Then write it down here, Na2. Then we have carbon, one carbon. You put one carbon here. Then we have how many oxygen? 1, 2, 3. You add it here. Then we have Na2CO3. In that sense, we've already prepared our what? Sodium ethanol. We already prepare our what? Our ethane. It means if you want to prepare your this particular ethane, you use sodium propanoate. If you want to prepare propane, you will use sodium butanoate. If you want to prepare butane, you will use sodium pentanoate. So like that, like that, like that. Then, and there is another thing that we have here, and we believe that if you want to prepare, there is another way we can prepare it, and this is what is called what? This is what is called preparation of what? Alkane from aluminium carbide. If you want to prepare alkane from aluminium carbide, we can also prepare methane by the action of steam on aluminium carbide. If you take a look at the reaction that we have here, we have Al4C3 in solid plus 16H2O in what? In gas. We supposed to have liquid state in that H2O, but because they made mention of what? They made mention of steam. That is the reason why we have it that way. So that is it. And another one is Grignard reagent. Grignard reagent is just like the hydrolysis. What is the meaning of hydrolysis? Whenever you see hydro means water. The breaking, the lysis mean what? The breaking down. Now the breaking down of water is known as what? Hydrolysis. So I'll continue from Grignard reagent. Then another thing is that we can answer any question that is what? That is based on alkane. You know, and you remember that whenever you are dealing with alkane, I said alkane is also known as paraffin. So that is it.